Everyone. Thought we'd talk a little bit more about economic growth. And as you may recall last time, we talked about how economic growth is measured in the increase in the productive capacities of the economy, not the numbers, not the amount of GDP created. So, and we said further that the economy, if this is real GDP or potential, potential or real, TIAL, or real, that the potential GDP kind of looks like that, increasing at an increasing rate or exponentially, because it increases at a steady percentage, but it shoots up like that because each time you're applying the percentage to a larger sum. So if you check, that's the potential growing, but if you check what's happening over time, you see recessions and peaks and recessions, troughs, recoveries, and the whole thing like that. Okay, a couple other things that I want to talk about here is that because that the growth goes way up like that in a relatively small percentage, the percentage of growth is important. Say that's, in this case, real GDP potential, say. And we find it goes up like that because of the compounding a bigger sum each time. If it's lower, say if this is 4%, which would be good growth, and this is maybe 2%, it would go up but not so high. In fact, to show you the difference that just a few percentage points can make, I'll introduce here a very useful tool that you can get if you happen to inherit some money. This is called the Rule of 72, which happens to be the year I graduated from high school, but that doesn't have anything to do with it. Basically, the Rule of 72 states that any sum of money you have will double in a period of time that is defined by 72 divided by the interest rate as a whole number, used as a whole number. So in this case, if, say, you were fortunate, say your aunt died and left you $100,000. I mean, it's not fortunate for the aunt, but it might be for you. Say you had $100,000. Well, if you put it in a savings account or some CD or some instrument, investment interest instrument that had a interest rate of, say, 4%, 72 divided by 4 is 18. So in 18 years, if you didn't touch it, you would have 200,000. So that shows the how much difference even a few percentage points makes. Okay, now we're going to introduce something now, how the potential. So we've talked about what economic growth isn't, and we talked about how the first diagram we were given in this course, the production possibilities illustration here. And let's say up here we have consumer goods, And down there we have capital goods. And we said that the production possibility curve goes something like that. That as you move from consumer goods to capital goods, you give up increasingly more consumer goods. But like we said, the potential is the growth of the economy. So in the Great Depression, this doesn't mean that the economy shrunk back or the production possibilities curve moved to the left. No, we were just in a position somewhere inside the production possibilities curve. You might consider economic growth to be very similar to what we think of as progress. Okay. Well, if we have a downturn, say the worst downturn we've had in recent memory was the 2008 recession, but we didn't lose progress. I mean, we didn't go back to driving 57 DeSotos and things like that. We didn't wear skinny ties necessarily. And what they used to call those things? Anyway, we didn't regress in terms of progression. Okay, and so economic growth would be a situation where the production possibilities curve goes out. And again, since capital goods are things that make other things, we can actually, and we forego consuming in the current era or current period by making capital goods. The more capital goods we have, the quicker or the faster we'll grow out like that. Well, there's another way that we can illustrate advancing economic growth there. And that is by introducing another illustration here. And in this case, we talk about the productivity of labor. Okay. So here we have the amount of labor put into the economy, or the quantity of labor, you might say. And up here we have real GDP that this labor manufactures, is able to manufacture. And what we will see is that the curve looks something, and this is the aggregate production function. And the curve you might see looks like this. Something like that. Well, why is it shaped that way? Well, remember, it's kind of a, universal law that we can't stand too much good things, and we get diminishing marginal returns from virtually anything. Like water, we had that illustration that if you're really thirsty, first glass of water is really good. Next glass of water is still probably pretty good, but not quite as good, and so on and so on. Well, when you add labor to a production process, initially you get a big return, a percentage return, because it involves specialization and everybody doesn't have, or one person doesn't have to do everything. But as you increase the labor, notice the addition to total productivity decreases. Okay, so the production function here is this shape because of diminishing marginal returns. Okay, well, what does all this have to do with aggregate growth or economic growth? We can view it in this respect. Let's first of all see where we get the labor in this market. And so on this axis here, we have a model of the labor market. We have a average wage here, and we have quantity of labor here. Okay, this is a labor market, so we have the demand for labor, and these are firms hiring workers, and then we have the supply of workers, which is up something like that. Okay, so at this equilibrium here, this is the quantity of labor, and this is the wage. Okay, the wage that is accepted here. So at this level of employment here, say at QL, say QL or Q star L here is right there. And so at that point, QL, that labor can produce this amount of GDP. And we'll call that GDP star. Okay. So what does that mean? Well, next we can introduce, so we got the labor market here, which I will erase now. What we can do is show the long-run aggregate supply. So we have a price deflator there, or say an average price level, and we have real GDP here. So at full production, at the natural rate of employment, which this Q star shows, they are able to produce this level of GDP. So let's state that is there, this level of GDP star, and that is with the economy running on full cylinders. No matter what the average price is, that's the amount the economy can produce. So this defines the long-run aggregate supply curve. It also defines the production possibilities frontier. So, this is what it looks like when the economy is working at full gear there. Okay. Well, how do we illustrate economic growth? Well, let's say something happens that makes workers more productive. Technology, human capital, which is skills, added skills training. So at every level of labor, the production possibilities, the economy can produce more. So what that means is that the production function will move up. Still be the same shape. Let's see, that's 1 and 2. So the production function moves up, okay? And at that level, they can produce a higher amount, say here, okay? Well, at this amount, this is more than the original production. So the economy has a new full bore production. So what that will do is that will move the capacity out like that, and the long run aggregate supply moves this way. So That's economic growth. And we'll make one more tape and explain it further and finish it out.